Hi everyone. So let's start this video, and in this video we will be talking about one-shot Capgemini technical assessment question preparation. First of all, we want your maximum support in this video because we will be solving a lot of questions which got asked in Capgemini a lot of times. Okay, so basically we will be discussing the questions again and again Capgemini is repeating, or the similar kind of questions Capgemini is asking. Believe me, if you will watch this video till the end, okay, till the end, you will say, Bhaiya, this is one of the best video for Capgemini technical assessment because the questions which I am solving is from this paper, and this paper is the Capgemini paper you can see here. Okay, it's the full Capgemini paper which I have, and I am solving the question from here. The best thing is I am exactly solving the actual questions asked by Capgemini. Okay, so this is the thing which we will be solving. Also, the main important part is it is not like we only have one paper, we have multiple papers. Okay, and how you can get it and how you can prepare for Capgemini. See, you can go with our Arjun series. Okay, in Arjun series you will be getting the two Capgemini paper actual screenshot. You will be getting a good idea like what kind of questions Capgemini do ask. So just go here in the company wise material. Here we have uploaded two papers for Capgemini, you can see here. Okay, so you can go through it. Apart from this, to practice for Capgemini, we have a lot of CS fundamentals mock test. If you will see here, it's 17 hours of mock test. Okay, and situational based question we have especially added for Capgemini because Capgemini do ask situational based questions, so you will be getting an idea what kind of questions Capgemini ask. Okay, pseudocodes we have added around 8.5 hours of mock test. Okay, see here, 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 mock test you have for pseudocodes, and all the things like gamified assessment also we have added, and everything. Not only for Capgemini, if you are preparing for any company you can purchase the series. The link will be in the description. Okay, and this series is valid for any company, so you will purchase this series one time and it will be preparation for the all companies. Because see, Capgemini do not ask quantitative reasoning and verbal questions, but we do have that also. Okay, so the link will be in the description for the Arjun series. Now let's talk about the questions and let's start our video. And I hope if you are watching this video, you liked this video till now. Okay, make sure to like this one. Let's start. The first question is, a production line queue is represented by 53342. Each unit can swap only with its an adjacent neighbor, and the identical units must preserve their original relative order. After sorting the queue in ascending order, what is the minimum number of swaps required? Okay, so basically they are asking a queue is represented like this. Okay, which is 5 3 3 4 and 2. Okay, each unit can swap only with its adjacent neighbor. Okay, so suppose if we want to swap, only the adjacent neighbor can be swapped. So suppose if we want to swap here, 5 cannot be swapped with 2, only 4 can be swapped with 2. Okay, because they are adjacent. Okay, so if we want to perform the swapping, only the adjacent neighbor can be swapped, and the identical units must preserve their original relative order. Stable sorting, we cannot change the order. Okay, like suppose this is 3 and 3, suppose this is 3 1 and 3 2. Okay, let's suppose we are representing them like that. Okay, it's 3a 3b. Okay, so after sorting we cannot do it's 3b and 3a. Okay, the order should be same. The a should come first and b should come to second. Okay, so the order should also we need to maintain. Okay, after sorting the queue in ascending order, what is the minimum number of swaps required? Okay, so they are asking what will be the minimum number of swaps to sort this. Okay, minimum number of swaps. Okay, so this is one important thing, and only the adjacent neighbors we can swap. Okay, so this is a question with one concept. I hope some of you guys know about that concept. I will discuss it. So see, first of all, this is the queue 5 3 3 4 2. Okay, now only for adjacent nodes we can swap, and if you will sort them, like if you want to sort them. Okay, and suppose if you are start doing this, that I will sort 5 with 3, then again I will sort 5 with 3. Like if you are doing these kind of steps, like first order is this, then I will swap it, then 3 will be come here, this 5 will come here, 3 will be here, 4 will be here, and 2 will be here. It is the one swap. Okay, This is the bachcho wala thing. Okay, you should do this in your college, not here, because you only have 1 minute to solve this question. So how we can do it? Okay, how we can do it, that is the most important part. Because see, anyone can do this question, but they will take 4 minutes, 5 minutes. That doesn't make any sense. We need to solve it quickly. So whenever you will be seeing a sorting related question, and when they are talking about the swaps, and they are talking about the stable sorting, there is a concept. Okay, there is a concept which we called as inversion count. Okay, inversion count. And if you know this concept, you can easily solve these kind of questions. It is not a tough concept, but we will do it. Okay, how we do it, I'll just give you an idea. First of all, this is our production line queue, which is 5 3 3 4 and 2. Okay, now let's suppose if we will sort it, then it will look like 2 3 3 4 and 5. Okay, this will be our final sort. Okay, this will be our final sort. Okay, so this is the order which we want, and this we have. Now there is something called inversions. Okay, now what is inversion? Okay, please try to understand with me. So basically, a inversion is related to the indexes. Okay, if I is less than j and a of I is greater than j, a of j, then we call it as inversion. Okay, then we call it as inversion. Okay, please try to understand this in the deep manner. Okay, what I'm trying to say, if I is less than j, okay, so this is the index 0 1 2 3 and 4. Okay, suppose 5 is here and 2 is here. Okay, so I is less than j because index is 0, index is 4. So 0 is less than 4. Okay, so this condition is true. I is less than j. And a of I is greater than aj. That means the 5 is greater than 2. That means they are not sorted, right? They are not sorted. Because whenever the I is less than j and a of I is greater than a of j, that means the array is not sorted. Because if you will take any sorted array, the inversion count will be 0, because there will be no element where the I is less than 0 and a of I is greater than a of j. Okay, you can take this example. Okay, so thus we count the inversion as 1 when this condition happens. Okay, when this condition happens, we count the inversion as 1. Okay, and it will solve our problem. It will solve our problem. How? Let's understand this. Okay, if you got this point now, if I is less than j and a of I is greater than a of j, that is the inversion. The question is solved automatically. Okay, let's solve it quickly. Okay, let's solve it quickly. First, here is 5. Okay, first here is 5. Okay, for 5, how many numbers are there which is in the right? Okay, there are total 4 numbers, which is 3 3 4 and 2. There are total 4 numbers which is in the right side of 5. Means these all numbers will break the condition of inversion, so we can count them in the inversion. So the for 5 the inversion count will be 4, because 4 numbers is there at the right side and they are less than 5. Then we have 3. How many numbers are there which is right side of the 3 and less than 3? Sorry, basically, uh, 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 so right side actually we want only the greater numbers. Okay, right side we only want the greater numbers. So how many numbers are there which is less than 3? This condition, that I is less than j and a of I is greater than a of j. So 3 is greater than 2, so there is only one number which is less than 3. Okay, so for 3 the inversion count is 1. Again for this 3, again for this 3, the inversion count is 1. Okay, now for this 4 the inversion count is 1, because 2 is here. And for this 2 the inversion count is 0, because no number is there in the right side. Now count the total inversion count. 4 1 1 1 and 0. So 4 plus 1 plus 1 plus 1, which is 7, it will be our answer. The total number of swaps required will be 7. Okay, so whenever this kind of question comes, you only need to count the inversions. Now I hope you got the concept of the inversion. I just want to explain you the basic concept of inversions, and I hope you got it. Now you can solve this question in less than 40 seconds, because whenever you will be reading this question, okay, I'll tell you how can you solve these kind of questions. Suppose you are reading this question and you know the concept of inversion. Now you don't need to do any kind of swapping. You read the question, a production line queue is represented by 53342. You read this line, they want the stable sorting, and they also asking about the minimum number of swaps. How you will be solving this? 5. How many numbers are right side? 4. They are less than 5. Okay, so 4 plus. Next number 3. How many numbers are there? And how many numbers are less than 3? Only 1. Okay, so plus 1. So again 3. How many numbers are less than 3 here in the right side? Only 1. So plus 1. 4. How many numbers are less than 4 here in the right side? Only ones. 1. And 2 is the last element. So answer will be 4 plus 1 plus 1 plus 1, which is 7. Answer. That's how you will solve in exam in basically 1 minute. Okay. But this concept should be clear. Okay. And these kind of concepts only I will be teaching you on the YouTube. No one will teach you the concepts like this which I am teaching you. Okay. The solution we have provided here, but the thing is, this kind of concepts only I'll teach on YouTube. Okay. So I hope you guys like the concept here. Again, we will be solving one question, but again, see, if you want to solve the Capgemini question, the actual paper you will be getting, like the question which I am solving is also from the previous year only. And the previous year papers are there for Infosys, Accenture, Capgemini, Mindtree, TCS, NQT sheet, Deloitte Annually paper, Cognizant aptitude, technical MCQ, Capgemini paper. Everything we have uploaded here in the company wise material. Okay, so you can check here, and for practice, a lot of mock test provided here for practice, which you can use for your practice. Okay, so let's talk about this now. So basically, this is our question. So next question. A developer is optimizing a BST delete function. The delete logic works as recursively search for the node to delete. If the node has two children, find its in order successor, copy the successor value into the node and then recursively delete the successor. If the node 50 is deleted first using this logic, then the node 150 is deleted. What is the value of the root's right child after both deletion? Okay, I think it is simple only. So they are saying this is the tree 100, 50, 150. Okay, then 50 has two childs 20 and 70, 20, 70, and 150 has two childs 120 and 170, 120, 170, and 170 has one child 160. Okay, and 70 has two childs 60 and 80. Okay, so this is our tree. Okay, they are saying we need to delete the nodes. Okay, which one we need to delete? Logic they have given here. First, we need to delete 50. Okay, so let's delete 50 first. They are saying recursively search for the node to delete. Okay, so 50 is here. If the node has two children, find its in order successor. So yes, it has two children. We need to find the in order successor. In order successor means the left most node of right subtree. These basic concepts you should know. Okay, and if you don't know about these concepts, see, I studied DSA in 2021, but still if you will ask me the questions, I can give the answers because my basic concepts are clear. Okay, so these basic things you should know. Okay, I also have not seen the solution yet, but this is the logic which they are asking. Okay, so the most node of the right subtree is the in order successor. Okay. So they are saying the copy the successor value into the node and then recursively delete the successor. Okay. So first we need to delete 50. Okay. What will be the leftmost node of the right subtree? So right subtree is this one. Okay. Right subtree is this one. Let's mark the right subtree. Okay. This is our right subtree, right? This one. Like this one is our right subtree. The leftmost node of the right subtree is 60. Okay. Okay, leftmost node of right subtree. We need to copy the value of 60 here in 50. So now 50 will be 60. Okay, and copy the value into the node and then recursively delete the successor and we will delete it. Now our tree will look like only this. Okay, so now this is deleted. Our tree will look like this: 100, 60, 20, 70, and 80. Okay, so the final look of the tree will be like this only. Okay, now this is our tree. Okay, this is our tree. Now they are saying 150 is deleted using the same logic. Okay, so for 150 the value of 160 will be copied here. Okay, because the left most node of the right subtree, and 160 we will delete. So this will be also deleted like this. Now this is our final tree. What they are asking, what is the value of the root's right child after both deletion? So value of the root's right child will be 160. This is the root and the right child is this one. So 160. Final answer. Okay. I think this is simple only. Let's check the solution. What is the final answer? Okay, final answer is 160. Okay. So I think this is simple only. Okay, so these concepts, if you know, it will become simple. In exam, how will you perform it? So see, you will be immediately copying the values and deleting the nodes from the leaves. And I think it can be solved easily in 1 minute. Okay, let's solve some other questions please. Okay, so let's start, and I hope you already liked. So this is the first type of question where they will give you one graph, and based on the graph they will ask you some questions. So this is our first type of question. This is the graph based. Okay, basically they will ask you majorly the questions from either BFS or DFS. Very very popular question. They will give you a graph, they will ask you the traversal of the graph. Okay, either BFS traversal or DFS traversal. Very common question in Capgemini. You can get like 1 to 2 questions from this topic in your pseudocode. So let's solve this. So this question they asked this year. So let's solve this one. So this is the question. Like a microservice dependency graph is represented using an adjacency matrix. The graph is undirected and contains 6 services labeled S1 to S6. Okay. So see, how many services are there? Total 6 services. S1 to S6. Okay, this is clear. The graph is undirected. This is very, very important. Okay, undirected graph means, see, if suppose we are going from 1 to 2, so we can also come from 2 to 1. Okay, so any vertex between them like 1 to 2, okay, we can travel from 1 to 2 and we can travel from 2 to 1. So this is the property for undirected graph. This is very important. Okay, so okay, so this is the representation which they have given. S1 0, S2 1, S3 2, S4 3, S5 4, yeah, S5 6. The ages in the graphs are S1 to S2, S1 to S3, S2 to S4, S3 to S5, S4 to S6, and S5 to X. Okay, which corresponds to the age list like this one, like 01, 02, 13, 24, 35, and 45. To better understand this, let's create a graph. So from 0, it is 0 to 1 and 0 to 2. Okay, 0 to 1 and 0 to 2. Then 1 to 3, 1 to 3, and 2 to 4, 2 to 4. Okay, 3 to 5. Okay, 3 to 5, and 4 to 5. So 4 to 5. So this kind of graph you can see here. So this kind of graph they told us. Okay, the adjacency matrix is built using that the matrix of u and v equals to 1 and matrix of v and u equals to 1 for each age u and v. Okay, this is the basic property of undirected graph. A DFS is performed starting from the vertex 0. So they are saying from vertex 0 we are doing an DFS. Okay, assume the DFS visits adjacent vertex in ascending order of vertex index. Which of the following is the correct DFS traversal? Okay, so they are saying like when we are starting our DFS traversal, it is going adjacent ascending order. Okay, so what will be the traversal of DFS? Okay, so I hope you guys already know the basic property of DFS. Then I will tell you how to solve these kind of question in 1 minute. Okay, because basically in exam you will be getting a 1 minute timer. Okay, so I will tell you how to solve it in 1 minute. Okay, so to explain it better, see, listen carefully. They are saying we need to go to ascending order. Like from 0 we have two options, either we can go 1, either we can go 2. But the point is very important, because sometimes maybe it can be random. From 0 we can go to 2, but no, they're saying we are going in ascending order. That means from 0 we will go to 1. Then what will be the traversal of DFS? Okay, now DFS is basically depth first search. Okay, that means we will be going to the depth of the depth of the edges or vertex. Okay, so how we do the DFS is basically you will start with the point and you will go to the depth of it. Okay. So if you are starting with a 0, you will not see the neighbors. You will just go in one direction. So from 0, we will go to 1. Okay. From 1, now we will not go again from 0 to 2. Then it will become BFS. Okay. So we traveled from 0 to 1. Now from 1, we will travel 1 to 3. Then from 3, we will be traveling 3 to 5. Then 5, we will be traveling 5 to 4. And from 4, we will be traveling to 2. This will be our DFS traversal. Okay. If it would be BFS, then we will be covering the neighbors, but it is DFS, that's why we will be going in only one direction. So our traversal will be 0 to 1, 1 to 3, 3 to 5, 5 to 4, and 4 to 2. This will be our traversal. Okay. So let's take our correct option. Why I am telling you in detail, because it is one question which they asked, but there is a possibility maybe they will be asking some more complex question there. So that's why 0 to 1, 1 to 3, 5, 4, and 2. This will be our answer, which is answer number B. Okay. So this will be our DFS traversal. So DFS and BFS traversal, they are asking a lot. Okay. Now let's talk about how to solve it in 1 minute. Okay. In 1 minute, if you want to solve it, see, first of all, just see some basic details that the graph is undirected, 6 services. See this one. This is very important. See this. Okay, it is the corresponding aging list already given, and perform the DFS is starting from vertex 0. Okay, these are the basic details and from ascending order. Now how you need to solve it in 1 minute only. Start from this one. So first 0, we will travel to 1. Okay, this one. Now we already reached out to 1, so we will look here where is the 1. So 1 is here. Okay, 1 is here. So from 1 we will travel to 3. Now look here, where is 3? 3 is here. So from 3 we will be traveling to 5. Okay, now look for 5. Where is the 5? Here is 5. So from 5 we will be traveling to 4. And from 4 we will be traveling to 2. So this is our answer. 0 to 1, 1 to 3, 3 to 5, 5 to 4, and from 4 to 2. Final answer. In 1 minute you can solve like this. Okay. But suppose if the graph is little bit complex, okay, if the graph is little bit complex, you need to use a little bit more mind. Okay. That's why I would suggest you to actually understand DFS and BFS in very detail from Google and or from any video, so that you can solve the question from it, because they are asking a lot of question from this. Okay. Second question, same question. Okay, same question, second question. Okay, the question is same, just the difference is they are asking for BFS travel. Okay, again the graph is same from 0 to 1, 1 0 to 2, from 1 to 3, from 2 to 4, from 3 to 5, and from 4 to 5. Now they are asking about the BFS travel, how we will how we will perform the BFS travel in here. Okay, so see, BFS travel is a neighbor travel. Okay, you can say it's a neighbor travel. Okay, so we will be covering the neighbor, and based on the neighbors we will be traveling. So see, first of all, we will print 0. Okay, because we are starting with 0. Now see the neighbor. The first neighbor is 1 and second neighbor is 2. Okay, so write 1 here. Okay, write 1 here. Okay, don't write here 2. Okay, first of all, write 1 here. After writing 1, then write 2. Okay, now this is from 0 we started. This is the first neighbor, this is the second neighbor. Okay, now have we explored the first neighbor? No. 0th, all neighbor we have already discovered, so 0 is gone. Now we need to discover the neighbors of 1 now. So what is the neighbor of 1? 3. So we will add here 3. Okay, is there any another any or more neighbor of 1? No. Now 1 is also discovered fully, so 1 is also done. Now we will again move forward. 2, what is the neighbor of 2? 4. Is there any other neighbor of 2? No. So 2 is also explored. So 2 is done. Now we have 3. What is the neighbor of 3? It's 5. Any other neighbor? No. So 3 is also discovered. We will go to 4. Fourth neighbor is 5. So 5 is already there. Okay, so all the neighbors is discovered. So fourth is gone. Fifth neighbor is for 5, the neighbor is 3 and 4. Both are already discovered. So fifth is done. So our final answer will be 0, 1, 2, 3, 4, 5. This will be our BFS travel. So it will be 0, 1, 2, 3, 4, 5. Answer number 1. Okay. Next question. Again, a very important question. So they ask case-based questions, case-based question on trees. Okay. Some students actually get scared after seeing this question, but these questions are not tough. You can easily do in 1 minute. Okay. Let's see here how we solve this. A company models two different coaching strategies for its cloud data center. Another thing which I want to tell you, if you want to practice and if you want the exact question full list, the solution I am talking about, all the screenshot of the questions are also available because these are the exact Capgemini paper, and we have already updated the paper here in our Arjun series mock test. So you can get the paper here in the company specific section. And to practice the mock test, we have already added the mock test here, which you can see here. A lot of mock tests are available, like 17 hours of mock test available in CS fundamentals, 6 to 7 hours mock tests are available in pseudocodes. We will be updating it more. Okay, so let's discuss about this now. A company models two different caching strategies for its cloud data center. Each caching strategy is represented as a binary tree. Cache design T1 balanced hierarchy. Okay, so they are saying they designed total two caching strategies. The first one is balanced hierarchy. The root is A has children B and C, B has children D and E, C has children F and G, and D has children H and I. So this is the tree representation. Okay, see here. This is the root, then it has B and C, then B has D and E, F and G, and D have H and I. Cache design T2, okay, is skewed hierarchy. Root is R has children S and T, S has child U, and T has child V. So this kind of representation is there in skewed hierarchy. Okay. Now, matrix definition. The performance matrix of T1 is the height of cache tree plus number of leaf caches, and the compliance matrix of T2, okay, is height of cache tree plus number of internal caches. Okay, don't be scared, I will be explaining you what they are saying. What is the difference between the performance matrix of T1 and the compliance matrix of T2? Okay, let's understand the question. They have given us the tree till now. Okay, just understand the question. Two trees they have given. The first one is there. Okay, the second one is here. Okay, till now the question till now only represents two trees. Okay, now they given two formulas, one for performance metrics and second one is compliance metrics. Okay, now they are saying what is the difference between the performance metrics of T1 and compliance metrics of T2. That means in the final we need to do T1 minus T2. Okay, so first we need to compute T1. What is T1? T1 is height of cache tree. Okay, height of cache tree plus number of leaf caches. So what is the height of this tree? See here, the longest till longest node we will be seeing the height. So from A to B, B to D, and D to H, the height is 4. The height is 4, right? So the height of the tree is 4. Okay, plus the number of leaf. How many leaves you can see here? 1 2 3 1 2 3 4 5. So 5 leaves are there. So it's 4 plus 5, which is 9. Okay, so the value of T1 is 9, right? The value of T1 is 9. Okay, now we need to compute the value of T2. The height of cache tree plus number of internal caches. What is the height of this one? Which is 3. R to S, S to U. Okay, height is 3. Okay, number of internal caches, internal nodes. Okay, how many internal nodes you can see here? 1 2 3. 2 are the leaves, right? So it's 3 plus 3, which is 6. Okay, now we need to find out. So value of the T2 is 6. Value of T1 is 9. Now we need to find the difference between T1 and T2, which is 9 minus 6. The answer will be 3. Simple. Okay, so answer is 3. Okay, let's talk about another question. Now this is the question which is very important, and please practice this question, which is convergence. Prefix, infix, postfix. Okay, these kind of evaluation 1 to 2 questions you can get in your Capgemini exam. Very, very important. The questions are easy. You can easily do in 1 minute. Okay, but a practice is needed. Like, see, I am teaching you the questions. Okay, I read data structures and algorithms in the year of 2020. It's 5 to 6 years. Okay. And I am teaching you this now because my concepts are still clear. Okay. I have a lot of practice. I solved a lot of questions. So the practice and the concepts will be in your mind if you understand that things carefully. Okay. And I am sure that I can teach the data structures and algorithms also this year. I did not revise it from last 3 years or 4 years. Why? Because at that time each and every concept was very clear in my mind. I practiced a lot. Okay, so practice makes you perfect. That is very, very important. And see, these questions like infix to postfix, postfix, infix, these kind of conversion you should know. So convert the above prefix expression into infix notation. Okay, so this is the question which they are asking. This is the expression. Then evaluate the infix expression using the following variables: a equals to 5, b equals to 3, c equals to 10, and d equals to 2. Okay, so this is the prefix expression, and we need to convert in infix. So when we want to convert in infix, we always start with the right. Okay, so this is the simple formula to convert it into infix, which is if there is any variable, put it in a stack. If there is any operator, perform the operation, and then after performing the operation, again push it in stack. Okay. Suppose we will start from here. So there is D. This is our stack. So we will push D here. Then there is C. So we will push C here. Then there is a divide. So if it is an operator, we will pop out the variables, two variables. So we will pop out D and C, and we will perform the operation. So it will be C divided by D. Okay. Now this is our operation. So we will pop out this, pop out this. Okay. Now our stack will be empty, and we will push it again. So now our stack will be C divided by D. Now we have B. B is a variable, so we will push B here. Then we have A here, so we will push A here. Now we have again our operator plus. So we will pop out two variables, which is A and B. We will perform the operation, and we will push it again in the stack. So A and B will be popping out, plus is there, so A plus B will be there. Okay. And we will push the A plus B in a stack. So it will look like this. Okay. So it will be A plus B. Okay. Now our stack is looking like this. It has divided by D and A plus B. Now it has multiplication. So the final answer will be A plus B multiplied by C divided by D. Okay. Now we need to compute it using the variables. Okay. The variables already they have given the value a equals to 5, b equals to 3. It is 8 multiplied by c divided by d. C divided by d, which is 5. Final answer will be 40. Simple. This will be our final answer. Okay, so this is our part 1 video. I already taught you a lot of patterns in this video, which will be a lot helpful in your Capgemini exam. Thank you so much for watching. The mock test link you will be getting in the description. Thank you so much for watching this video. Understanding the actual question Capgemini asked, also we will be solving the basic concepts around that. Okay, so first of all, make sure to like this video and show your maximum support. And you will ask, bhaiya, how you are sure that it is a Capgemini question? See here, this is the full paper for Capgemini. We already have the full paper of the Capgemini. They did ask previously. But if you want to access the paper, also you want to prepare for Capgemini, we have the Arjun series, and it is for all companies. It is not like it is only for Capgemini. So if you also want the previous year paper, you will be getting here in the company wise material. There are total two papers which we have uploaded for Capgemini. Apart from this, to practice like pseudocodes and all CS fundamentals, you will be getting a lot of mock test for practice. So CS fundamental in pseudocodes, you will be getting ample amount of mock test for practicing Capgemini. Apart from this, we have gamified assessment and all. Also, uh, if you want to prepare for other company as well, there is a lot of things available for the other companies. So Arjun series is for all companies. It is not like it is only for Capgemini, but you will be getting the material for all companies. Okay, so you can purchase it. The link will be in the description. So let's start. So see, the topic is basically which we will be discussing in this video will be operators. Okay, very important. And left shift, right shift. Also, we will be understanding the actual question asked by Capgemini. So you will be getting the level that how much time you will be getting to solve that question. Okay, so let's start. And if you have not liked this video yet, make sure to like this video. See, सबसे पहले we will understand about the AND operator. It is very easy. So see, first of all, let's talk about the decimal to binary conversion very quickly. So suppose you want to convert 5 into binary. So how we convert 5 into binary? There are total two tricks. So you can divide 5 by 2. So it's 2 to the 4, so it will be 4, and 2 to the 4, and what will be the remainder? 1. Okay, then 2 can divide 2 fully, but 2 1 is 2, so 2 1 is 2, but it can divide it fully, so the remainder will be 0. Then 1 is here, so 1 is go as a remainder only, so 1 here, so it is 101. Okay, 101. So this is the conversation from decimal to binary. Okay, so this will be our conversation. So this is the actual trick. Okay, to convert any number to binary. Okay, so see, and we read the numbers from last. So 101, like this we read. Okay, so for example, we want to convert 3, so 3 divided by 2, so 2 ones are 2, remainder is 1. Okay, now here is 1, so again 1 will come here, so 1 1, so it will be 3. Also, if you want to quickly convert it, okay, for the smaller numbers it will be very easy to quickly convert it. Okay, I will just give you an idea how to quickly convert it. So see, basically it is nothing. So if you want to convert 5, so it will be 2 to the power 2 plus 2 to the power 0. So basically wherever it is a 1, it is a 2 to the power. So last bit will be 2 to the power 0, then 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5. It is good if you can remember the 2 to the power till 15. Okay, so if you remember till 2 to the power 15, it is very easy to convert the numbers into the binary. Okay, because we already know about them, right? So 5 is nothing but 2 to the power 2 plus 2 to the power 0. So that will be 5. So 2 to the power 0, 1 will be there. 2 to the power 2, 1 will be there. Okay, so that's how we convert. So what is AND operation? For AND operation, 1 and 1 is 1. Apart from this, everything is 0. So if there is 1 1, it will be a 1. 1 0, it will be 0. 0 0, it will be a 0. And 0 1 will be a 0. Okay. So 1 1 will be a 1. So this is the AND operation, basic AND operation. Okay. So if you want to perform the AND operation between 5 and 3, so first we will convert 5 into the binary. So it will be 0 1 0 1, then 3 will be 0 0 1 1. So if we convert it, so it will be 0 0 0 1, because 1 1 is 1, 0 1 is 0, 1 0 is 0, and 0 0 is 0. So result will be 1. Okay. OR operators. So OR operators is also similar, only the difference is 0 1 will be 1, 1 0 will be 1, 1 1 will be 1, and 0 0 will be 0. This is the basic difference. So 5 or 3 will be 1 0 1 or 0 0 1 1. So 1 1 will be 1, 0 1 will be 1, and 1 0 will be 1. So answer will be 7. How we convert this into a decimal? Like it is 1 1 1. Okay, so 2 to the power 0 plus 2 to the power 1 plus 2 to the power 2. Okay, so it's 4 plus 2 plus 1, so the answer will be 7. Okay, that's how we convert it into a decimal number. Okay, I think these are the basic things you guys already know. Okay, but we are just revising them, then we will be solving the actual question. So XOR is basically, see, if there is let's understand about the XOR operator. So basically XOR operator result bit is 1 if the bits are different. Okay, so if the bits are different, like it is 0 and 1, then it will be 1. It's 1 0, then it will be 1. But if the bits are same, like 0 0, it will be 0. 1 1, it will be 0. Okay, so the bits should be different. So this is the basic funda for XOR operator. Okay, and XOR operator very important in Capgemini. Also, please make sure that you do the conversations quickly, because conversion from decimal to binary will be needed a lot in Capgemini exam. Talking about the left shift, again an important topic, but very easy. If you want to perform the left shift, you don't need to actually perform the whole thing. Okay, I'll just tell you how we do it. Okay, so basically there are two types of number. Okay, either it will be odd, and either it will be even. So see, in left shift what we do, suppose we want to shift 4 by 1. Okay, or we want to shift 4 by 2, whatever it is. Okay, so understand this thing. 4 is basically 0 1 0 0. Left shift means one will be shifted by one place. Like each number will be shifted by one place, right? Each number will be shifted by one place. So one will become here, one will come here, so it will be 1000, correct? So what it is? Okay, try to understand what it is. So it is basically 8, right? So if you want to convert any number using left shifts, okay, just multiply it by 2 to the power and whatever it is. So you want to basically left shift by 1, then it will be 2 to the power 1. So you will multiply 4 by 2 to the power 1, which is 8. Okay, let's take another example. Suppose it is 5. Okay, so now try to understand. 5 is a odd number. So 5 is a odd number. Okay, so how we will be converting 5? Let's see. Okay, so 5 will be 101. For each and every odd number, the last bit will be 1. Okay, because we will be adding plus 1 in the odd, right? So the last bit will be 1. So if you want to left shift, it will be 1010, right? And if you will convert it, what it is, 2 to the power 3, right? Plus 2 to the power 1, which is 10. So again multiply by the 2 to the power. So 5 left shift by 1 is 5 multiplied by 2 to the power 1, which is 10. But suppose if you want to convert the left shifts by 2 bits, let's take an example. Let's convert something using 2 bits. Okay, so let's understand about the left shifting by 2. Okay, so suppose we want to shift 3 by 2 places. Okay, so 3 is basically 0 1 1, correct? 2 to the power 0 plus 2 to the power 1. Okay, now to left shift it, it will be, suppose it is 0 0 1 1. Okay, then 2 times left shift 1 1 0 0. So it will be 2 to the power 0 1 2. So 2 to the power 2 plus 2 to the power 3, which is 8 plus 4, which is nothing but 12. So how we reached out here? So we are shifting 3 by 2 left shifts. That means we will multiply it by 2 to the power 2, which is 4, so it will be 12. So that's how we do the left shifts. We just multiply it, okay, by 2 to the power. And same for right shift, what we do, we divide it by the 2 to the power. So suppose we are doing 8 shift 2 times. Okay, so what will be our actual answer? Okay, so if you want to right shift by 2 for 8, it will be 8 divided by 2 to the power 2. So it will be 8 divided by 4, so it will be 2. So answer will be 2. Okay, so this is the right shift. Now let's solve the actual question asked by Capgemini. Let's understand this. Okay, this was the exact question Capgemini asked this year. Okay, very important. So Capgemini asked this question, exact this question. Let's solve this. Okay, and you need to solve it in 1 minute in exam. How you can quickly do it? So see, if you are taking time in the conversation, it will take time. Okay, but if you can do the conversation quickly, okay, conversation quickly, then this question will be easy. For example, there is 13. Okay, 13. How you can break out 30 in the terms of 2? So it will be 8, okay, plus 4 plus 1, correct? You just no need to do divides, right? So it will be 2 to the power 3, 2 to the power 2, and 2 to the power is a 1, 0. So now you just need to place the ones here. So it will be 1 0, then 1, then 1. Okay, so it's 2 to the power 0 plus 2 to the power 2 plus 2 to the power 3. That's how it is 13. Simple. So that's how we do the conversions. Don't do it like by dividing it by 2, so it will take a lot of time. That's why I told you that please learn 2 to the power 15 till 2 to the power 15. Okay, why is 9? So it will be basically 8 plus 1. Now we know what is 8. 8 is basically 1 0 0 and 0, and it is 1, so 1 here. So 1 0 0 1, it will be 8. Okay, so we already got 13 is basically 1101 and 8 is 1001. Now it is very easy for us, right? Okay, now it is very easy for us when we converted it. Now it is very simple. Okay, the main thing is how you are converting the things. If you do the conversion quickly, then it will be very very easy for you. They are doing x and y, so this is x and this is y. So x and y we need to do. Okay, so x and y we already discussed about, and it is only 1 1 is 1. Okay, so it will be 1 0 0 and 1. Okay, so this will be x and y. Okay, so it will be again 9. Okay, left shift by 1, so basically multiplying it by 2, it is 18 plus x XOR y. Okay, so x XOR y. So this is x and x XOR y. So XOR we already discussed, same symbol 0. So it will be 0, 0, 0, 1, and 0. So it's 1 0 0 to the power 0 to the power 1. So it basically 4. So 4 right shift by 1 means 4 divided by 2. Okay, so 4 right shift by 1 is 4 divided by 2, which is 2. Okay, so it was 18 plus 2 minus. Okay, so x or y. So x or y will be 1 1 will be 1 0 0 0, 1 0 is 1 and 1 1 is 1. So again this is 13. Okay, so 13 mod 5. So if we will be doing 13 mod 5, it will be 3. Okay, so if it is 3, so it is 18 plus 2 minus 3, right? So 20 minus 3. So 20 minus 3 is 17. So the final answer will be 17. Okay, so the final answer will be 17 for this question. So let's check it. Okay, so check here. Uh, this is right. Okay, x and y will be 18, x or y will be 2. Okay, so 18 plus 2 20, and x or y is 13. So 13 mod 5 will be 3. So 20 minus 3 is equals to 17. So this kind of questions you need to do in 1 minute. Okay, now this is the questions for practice which you can do. I'm just telling you, take the screenshots from the video. Okay, this is the question 1 just for the practice. Question 2. Okay, and try to solve them. Okay, try to solve them quickly so you can practice them. Okay, so I hope this video helps you out with this concept. This is our free preparation series, okay, for Capgemini, which you can watch for your preparation. The playlist link will be in the description. Also, the link of the mock test will be in the description for Arjun series mock test for all assessments, which you can use for your practice. Thank you so much for watching.